Hey everyone, Mr. Voikin here, and Unit 8, Lesson 4 on the way. All right, so we're looking at the slope of a line. We've already looked at how to determine the length of a line segment and then find the midpoint of a line segment, and now we're going to be looking at its slope. And as indicated right here, the slope equals rise over run. So rise is sort of what is going up and down. Okay, and on the Cartesian coordinate system, that would be the y direction. And the run, it is what is going right and left. And again, on the Cartesian coordinate system, that would be the x-axis. So basically the rise is going to be your change in the y, and the run is going to be your change in the x. So slope really is just equal to the change in y over the change in x. And as indicated below right here, and you should know this is quite obvious, that the rise, if we're going up, we would call that positive, and if it's going down, we would call that negative. And for the run, that it would be to the right is positive and to the left would be negative. Okay, let's take a look at class example number 1. And before we start this, I just want to inform you that the slope, which we usually call lowercase m, which is the slope, okay, which again we said was rise over run, which is the change in y over the change in x. Now it's either going to be positive or it's going to be negative. So a positive slope will move up and to the right, and a negative slope will move down and to the right. So if we take a look at this first point, A to B, going from A to B, the left to the right, it's moving in an upwards direction, so that would be a positive slope. Now let's take a look at the next one, which is going to be C and D. And again, moving from the left right here to the right, we're going in an upwards direction. So again, that would be a positive slope. And looking at EF and moving to the right, it's going down. So going to the right and down, that is going to be a negative slope. So again, just to go over that one more time because it's quite important. If I look at this slope, it's moving to the right and up, that is positive. To the right and up, that's positive. And to the right and down, that is going to be negative. Okay, so looking at the table below, they want us to fill in the rise and the run of line AB, line segment CD, and line segment EF. So first of all, let's start at AB, and it doesn't really matter where you start and where you go to. It'll all work out the same. It's just a matter of dealing with the integers. So in this case, or in all three cases, I'm going to start at the first one, which is A, and go to B, C, go to D, and E, and go to F. So how do I get from A to B moving in only vertical and then horizontal directions? So moving vertical, I'm going up 2, and moving horizontally, I'm going 1, 2, 3, 4, 5, 6, 7. So in this case, the slope is going to be rise of 2 over the run of 7. So let's take a look at C and D. Okay, well, again, what are we doing first? We're dealing with the y first, the change in y. So coming down, how far did I go down? 1, 2, 3, 4, 5. So remember, going down is a negative. And then from that point, to go over to D, I went over 1, 2, 3, 4. And I went to the left. Okay, so and again, going to the left is negative. So what we've got here is a negative 5 over a negative 4. And you know that when we have a negative over a negative in fraction form, it's actually going to be a positive. So the slope is better written as 5 over 4. So let's deal with line segment E and F. Okay, in this case, I'm coming down 1, 2, 3, 4, 5 to get down to there. And because it's downwards, it's negative 5. And then I'm moving to the right, 1, 2, 3 to get over to F. To the right is positive. So now what I have is a negative 5 over 3. And this can be also written like negative 5 over 3, like that. All right, something new here called an investigation number 1. We're going to look at this one line segment that's going from A to D. And it's got a whole bunch of sort of smaller line segments in between. And we're going to be taking a look at the slope. Well, any line from any point to another point is going to have the same slope. So no matter what, everything here should end up being the exact same once we fill in this area and simplify that. Okay, so let's see if that's true. So we're going to look at line segment AB, and I like going up first, so it's going up 2, and then it's moving over 3. So the slope is going to be 2 over 3, a positive slope, because remember again that this is moving to the right and up, so that is a positive slope. Okay, so like I told you, that means that every one of these, because it's the same line, should also have a slope equal to 2 over 3. So let's see if that's true. How do I get from A to C? Well, now I'm going to move from here all the way up to this point, which happens to be 1, 2, 3, 4, 5, 6, 7, 8. So it's moving up 8. And then how far am I moving over to the right in my run? Well, I'm moving over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 8 over 12, I can now take that and divide 8 by 2 and get 4 over 6. And I can divide that by 2 again and get 2 over 3, and that's the slope that we're looking for. And what about AD? Well, again, now it's going up here to that point, which happens to be up 10, and then it's moving over to the right, and that's going to be 1, 2, 3, 15. So if we look at the math again, we're starting with 10 over 15. If I divide the top by 5, I'm going to end up with 2. And if I divide the denominator by 5, I'm going to get 3. And there we go. Back to our slope that we already determined before we started this investigation. So if we follow the same pattern, no matter what is here and what is here, it should simplify to a slope of 2 over 3. On to investigation number 2. We're looking now at the slopes of horizontal and vertical lines. We previously looked at lines, the slope of line segments that are diagonal. So grid number 1, these are our horizontal lines, and grid number 2 are the vertical lines. So we just need to apply the same principles, and I'm just going to choose one example in each case. So on grid 1, I'll look at line segment AB. So remember, slope is going to be the change in y over the change in x. So what is the change in y? in line segment AB? Well, it doesn't move up or down, so the change in Y is going to be 0. And the change in X is going to be 8 or negative 8, whichever way you went. But no matter what, when we take a 0 that's in the numerator and we divide it by any value, positive or negative, in the denominator, we get a value of 0. So any horizontal line, doesn't matter the length or its position, will have a slope of 0. And what about vertical lines? Well, we'll just take a look at line segment IJ here. Again, looking at the principle of change in Y over change in X, indicating its slope. And what is the change in Y here? It happens to be, looks like 7. And the change in X, it's not moving left or right at all, so that is going to be 0. And you know through mathematical theory that we cannot divide any number by 0. So in this case, this is not possible. You cannot do it. If you tried to punch this into the calculator, it's going to bring up some type of an error. So what we say in mathematics is that the slope is undefined. All right, and investigation number 3, positive and negative slopes. I already mentioned this right at the beginning. So you should be able to identify that everything in grid number 1 has a positive slope because it's moving to the right and up, to the right and up, to the right and up. And everything in grid number 2 has a negative slope. It's moving to the right and down, to the right and down, and to the right and down. So if we look at this grid below here, a table for grid number 1, it's saying let's find the slope of line number 1. So what you need to do is you need to find 2 points that are crossing through lines at known values. So right there and right there. So I remember from the previous examples, I don't need to start at the beginning and go to the end, and you can actually see they're just sort of floating in the middle of between these lines. So I would just be estimating their value. But these 2 points that I'll label A and B in this case are going between 2 values. So what am I doing? I'm going up 2, so that has a slope of 2 over, and I'm moving to the right 1, 2, 3. So it has a slope of 2 over 3, and it is positive. When I look at line number 2, again, I just got to find 1 point right there and another point right there. And again, what am I doing? First, I'm going up, and that's going to be 1, 2, 3, 4, 5. And then I'm moving to the right 2 units. So this has a slope of 5 over 2. And the third one, again, find 2 points. So there's 1 point, there's 2 points, and I'm going up 1 unit, and I'm moving to the right 1, 2, 3 units. So it has a slope of 1 over 3. Now, I'm not going to do the same work that I just did there because it's just exactly the same. But basically, if we look at line number 4 and we find some points and we calculate the slope, what we're going to end up with is a negative slope. So in this case, it's going to be negative 2 over 3. It's the same slope as line number 1. Line number 5 has the same slope as line number 2, except in the negative direction, so it's negative 5 over 2, and line 6 has the same slope as 3, except in the negative direction, so that's going to be negative 1 over 3. All right, moving forward, class example number 2, we've got a word problem and we have a diagram of some sort here. There's a man standing on a roof. This question I don't really particularly like that much, but we'll go over it anyways. There are a few valid, important points that can be pulled from it. So starting off, the word pitch. So the pitch is the same thing as slope. So rise over run, except we use the word pitch when we're referring to a roof. Okay? So if we look at this roof right here, we say there's the angled line, and basically it's forming this right angle triangle right there. And by determining the rise and run, we can determine the pitch of that roof. And we've got another roof line right here, which again would form another right angle triangle, and calculating the change in y over the change in x. So change in x over the change in y, we can determine its pitch. All right, so question A says estimate, and I'm glad they actually used the word estimate because there's no real way to determine the exact slope of this roof because of the perspective. You need to be looking at it straight on, and we are not looking at it straight on. So you would just do the best you can to find a couple points that are sort of lined up on there, and again go up and over to those points and count the number of units of change in the y direction over the number of units of change in the x direction. So if I'm looking at the change in y over the change in x, that being our slope, in this case I would say it's around 2 over 7. So rather than saying it equals, I'd probably replace that with a approximately 2 over 7. And it says, part B says, could the grid be used to estimate the pitch of the roof that the worker is standing on? It's even worse than the other one because, again, it's at a really bad point of view. The perspective that we're looking at it from would almost make it impossible. So, not really. And I would even say with the first one, not really as well. Okay, but like I said, at least this first one right here is definitely a little bit better in perspective than the second one. All right, well, last two class examples. Let's get through them and move on to the assignment. So class example number 3, it says they want you to draw a line segment. So a line segment is a line that does not go on forever in any direction. It has 2 endpoints. And in this case, it passes through the point -4, 2, and it has a slope that is -2 over 3. So remember what we know about a negative slope, that coming from the left to right, it will then move downwards. So we're going to be looking for a line that is in that direction right there. And it says right here, to make sure that the line you create, or the line segment, goes to the x-axis and the y-axis, and then to find 3 other points on that line. So let's begin with plotting the first point we know, which is -4, 2. So I want to move backwards 1, 2, 3, 4 from the origin, and that's in the x direction, then +2, and that will be our first point right there. So let's just make a point at -4, 2, and now we're going to deal with the slope. So it's -2 over 3. So the slope is -2 over 3. So it can either be negative 2 over 3, or it can be 2 over negative 3. So in the first case right here, this would be, remember the top is the change in y and the bottom is the change in x. So if we're looking right here at a negative 2, that would be down 2. And then a positive 3 would be right. So this is down and right. Okay, so if I come from this point, down 2, 1, 2, and then right, 1, 2, 3, we get a point right there. So I'll just identify that point right there, and we can continue to do that for as many other points as we want. So I'd move down 2, 1, 2, 3 over 3, down 2 over 1, 2, 3, down 2 and over 1, 2, 3. Now, if we look at this second or third example, I guess, I've got a positive 2, which would be up 2, and I've got a negative 3 on the bottom, which would be left. So if I go back to our original point, which is right there, we're going to be going from that point up 2 and then left 3. So if we go back here, it's going to be up 2 and left 3 and up 2 and left 3 again, and I get a point right there. But because I'm trying to do a line segment, I wouldn't want to go right to the end, so I'll delete that last point right there. And now what we need to do is draw a line that starts at that point and goes through all the other points and ends right there. So you can see I've got a line segment going from, we'll call this point A down to point B. And the red one right here was what we started off with, which was negative 4, 2, and it says to label 3 other points. So if we look at this one right here, it's going to be right 2, down 2, so that would be a 2 and a 2. And if I chose the one that was up top here, it would be negative 7 in the x and 1, 2, 3, 4 in the y. Okay, now last class example, number 4. It tells us that we have a line segment again, and this time we know it has a slope equal to negative 5 over 7. Again, that tells us that it'll move to the right and then go down because it's negative. And what does it tell us? It's got a rise of 12. Okay, and what do they want us to figure out? They say to calculate the run and leave it as an exact value. So that means leave it as a fraction or a value other than a decimal. Okay, so let's see what we're going to do here. I'm going to start off with knowing making 2 equivalent fractions, because remember the slope is always the same, and we can have different values of a slope, and then sort of how can I say this, we would simplify it, right? So remember, if I got a slope of 18 over 6, that's this, if I divide this by 2, that's going to be 9 over 3, which is the same as divide 3 into there, 3 over 1. So all of these are the same slope, same ratio between the top and bottom number. So if I've got a negative 5 over 7, remember what we're dealing with here is the rise over the run is going to be equal to another rise, whoops, that says run, another rise over run. So if we look at, excuse me, what we got here, it says that the rise is 12. So that would be on the top. And then it says, what is the run? Now we know that this is a negative 5 over 7. So remember from previous examples, that means that this negative can be associated either with the rise or with the run. I have to put it in one of these positions. Now notice that the value 12 is positive. So in this case, the rise is positive. So we would want to make the rise on the other equivalent ratio also positive. So that means this negative would be associated with the run. And remembering back a few units, a few months ago, when we're comparing ratios, we're saying that they are equal. And if they're equal, we can use cross multiplication to solve for x. So how are we going to do this? 5 times x is going to be 5x equals negative 7 times 12, which is negative 84. Now to isolate the x, we're going to divide it by 5, leaving us with the value of 1x equals, and divide the right side by 5, and we've got negative 84 over 5. Now remember, it's telling us to leave this as an exact value. So I wanted to first check if I can simplify negative 84 over 5 in any way. And there is no way, there are no common factors between 84 and 5. Therefore, the answer is going to be the x in this case, which is the run, equals negative 84 over 5. And there we go. Now we're moving on to all of the assignments, questions, which are on page 523. And then the answers will be at the end of all that on, looks like, page 528. All right, see you in class.